They've given you the equation of the directrix. They've given you the focus of the parabola. You want to find the equation of the parabola. What do? You take any point P on the parabola, x comma y. Then what will cause it to be a parabola? Distance from the focus equal to the distance from the directrix. SP squared must be PM squared, will cause P to be on the parabola, right? So SP squared is PM squared. What is SP squared? X minus 3 whole squared plus y plus 4 whole squared, right? That's SP squared. XY distance from this line, right? That's equal to x minus y plus 5 whole squared by root 2 whole squared, right? Square of the distance from this line of this point x comma y. That'll be the equation. Yes or no? Now you cross multiply and simplify, you will get the generalized equation of this parabola. And do you realize there would be an xy term that will appear here? That means it must be a parabola whose axis is inclined to the x-axis, right? Stand by. I'm assuming all of you got this right. We want to find the locus of the circumcenter of triangle OAB. We want to find the locus of the circumcenter of this triangle OAB. It's a right angle triangle. Where will its circumcenter be? The midpoint of the hypotenuse. The midpoint of the hypotenuse would be its circumcenter. Yes or no? And you can draw very many perpendicular chords from O. Several pairs of OA and OB perpendicular could be drawn. So several such triangles OAB would be obtained. And therefore for each such triangle there is going to be a hypotenuse AB which will have a midpoint. If you populate all the midpoints, you will get a certain locus out of the midpoints of all the ABs. And that will be the locus of the circumcenter of the very many triangles that could be created, right? So now this is the origin. Let me call this point T1. So this will be 8 T1 squared. T1 is a parameter, right? T1 is not a fixed number because A could be any point on this, right? T2 is also a parameter. This would be 8 T2 squared comma 2A T2. And M is the midpoint of this, H comma K. I want to find a relationship connecting H and K deprived of the parameters T1 and T2. And then I want to generalize. That will be the locus of the midpoints of AB, where M will be the circumcenter of triangle OAB. Yes or no? Now, if H is the circumcenter, can you see that 2H? H would be what? This plus this by 2, right? Midpoint of AB. So 2H would be A into T1 squared plus T2 squared. 1, 2. K. So 2K would be 2A into T1 plus T2. That's second condition, right? And third, slope of OA. What's the slope of OA? Slope of OA is 2A T1 minus 0 divided by A T1 squared minus 0. That's the slope of OA, which is 2 by T1. Yes or no? Similarly, what's the slope of OB? Slope of OB is 2 by T2. But OA and OB are perpendicular lines. So product of the slopes is minus 1. Slope of OA into slope of OB is minus 1, or 4 by T1 T2 is minus 1, or T1 T2 is minus 4. T1 T2 is minus 4. Yes or no? T1 T2 is minus 4. So the third condition is T1 T2 equal to minus 4. Now I need to eliminate T1 T2. I need to eliminate T1 and T2. Yes or no? Very simple. Look at this. Or you can just look at this also. 2H is A into T1 squared plus T2 squared is what? T1 plus T2 whole squared minus 2 T1 T2. How about it? Hai na? 2H is A, T1 plus T2 whole squared. But T1 plus T2 is what? T1 plus T2 is K by A. Right? So this is A into, this is K by A, T1 plus T2. So K square by A squared minus T1 T2 is minus 4, so plus 8. That's 2H. Yes or no? Now all that you need to do is generalize. So replace H by X and K by Y. So 2X is A into Y squared by A squared plus 8. So X is a quadratic and Y, it's going to be a parabola. It's going to be a parabola whose axis is parallel to the x-axis. If x is a quadratic in y, it's going to be a parabola whose axis is parallel to the x-axis, like we discussed in the last class, right? So the locus of these circumcenters is going to be a parabola whose axis is parallel to the x-axis. So in the next problem, they've given you the coordinates of the focus, they've given you the coordinates of the vertex, and they want you to find the equation of the parabola, right? So obviously the line joining the vertex to the focus will be the axis of the parabola. Yes or no? This will be the axis of symmetry of the parabola. And can I find the equation of this? Yes. Y minus 2 is x plus 2, right? Given 2 points, I can find the equation of the line. Y minus 2 by x plus 2 equal to, now the slope is 2 minus minus 6, 8 divided by 4. Yes or no? Do you realize this? See, 2 minus minus 6, y2 minus y1 minus 2 plus 6, 4. That will be the equation. Yes or no? So that's like twice x plus 2. That's the equation of the axis. So this is like y equal to 2x plus 6 is the equation of the axis. 4 and 2, 6. That's the equation of the axis. What? This is the focus, this is the vertex. Line joining the focus with the vertex is the axis of symmetry of the parabola. So given 2 points, can you find the equation of a line? How do you find? Y minus 2 divided by x plus 2 equal to the slope of the line. Slope of the line is what? 2 minus minus 6, 8 divided by minus 2 plus 6, 4. That's the equation of the axis, right? Given 2 points, you can find the equation of a line. Na? So that's y equal to 2x plus 6 is the equation of the axis. Now, do you realize that the directrix will always be perpendicular to the axis? Directrix will always be perpendicular to the axis. Now, what's the slope of the axis that we have obtained? Slope of the axis is 2, isn't it? So, what would be the slope of the directrix? Minus half would be the slope of the directrix, right? Now, this is the foot of the perpendicular onto the directrix from the focus. This is, say, z, and say it has coordinates h comma k. Now, do you realize this is a units, this is also a units? That means vertex must be the midpoint of zs. Vertex is always the midpoint of zs. Yes or no? This is also a units, this is also a units. So now I can apply section formula. So minus 2 equals h minus 6 by 2. Minus 2 equals h minus 6 by 2. So that gives me h equal to 6 minus 4, 2. Right? Similarly, k equal 2 equal to k minus 6 by 2. H minus, yeah, yeah. So that gives me k equal to 10. Yes or no? So I know the coordinates of this point. How much is it? 2 comma 10 are the coordinates of this point. I know the slope of the directrix. So can I find the equation of the directrix? So the equation of the directrix then is going to be y minus 10 by x minus 2 equal to the slope minus half. That's the equation of the directrix. Yes or no? Not a confusion, right? So I get like 2 into y minus 10 plus x minus 2 equal to 0. No confusion. 2 into y minus 10 plus x minus 2 equal to 0. That's the equation of the directrix, which boils down to x plus 2y minus 20 minus 2 minus 22 equal to 0. I am assuming I have not made a mistake. That's the equation of the directrix. And I know the focus. I know the focus, I know the equation of the directrix now. Very clearly, if px comma y be any point on the parabola, then its distance from the focus would be equal to its distance from the directrix. SP will be equal to pm. And sp squared would be pm squared. What is sp squared? X plus 6 whole squared plus y plus 6 whole squared equal to the distance of this from the directrix. That means that's distance from this line, which is x x plus 2y minus 22 by root 5 whole square. Cross multiply and simplify, that's going to be the equation of the required parabola. How about it? Clear, na? There is a parabola, and this parabola is y squared equal to 16x, and there is a point on the parabola 16 comma 16. A normal is drawn at P, a tangent is drawn at P, and this is the axis of the parabola. The tangent intersects the axis at A, the normal intersects at B. Now a circle is drawn passing through PAB. A circle is drawn passing through PAB. If a circle is drawn passing through PAB, would you want to not believe that AB must be the diameter of that circle? AB must, because this is angle in a semicircle, 90 degrees. So AB must be the diameter of the circle, right? AB is the diameter of the circle. Now I can show that the midpoint of AB for all tangents, the midpoint of AB will always be the focus. The midpoint of AB will always be the focus. How? See any parabola. Say this is a point P, say 80 squared comma 280. Right? And I draw a tangent. What's the equation of the tangent? Yt is x plus 80 squared. Right? And how do I find the intersection with the x-axis? Put y equal to 0. So this point is going to be what? This point is going to be minus 80 squared comma 0. The point where the tangent intersects the x-axis. Yes or no? You know? Now this is a normal. The normal at t would have slope minus t. Yes or no? So what would be the equation of the normal? Y minus 280 is minus t into x minus 80 squared is the equation of the normal. Right? And how do you find the intersection of the normal with the axis? Put y equal to 0 again. Put y equal to 0, then x will give you x of b. So if you plug in y equal to 0, you get, if you plug in y equal to 0, you get x equal to 2a plus 80 squared. You get x equal to 2a plus 80 squared if you plug in y equal to 0 in this. Right, Partho? Yes. And they are perpendicular to each other. The tangent will always be perpendicular to its corresponding normal. Right? Hey, what's the midpoint of AB? Section formula? 2a plus 80 squared comma 0. x1 plus x2 by 2, so that will be a comma 0 would be the midpoint of AB, which is the focus, of the parabola. Yes or no? Which is the focus of the parabola, isn't it? So which means a circle drawn passing through AB would have its center at the focus a comma 0. Yes or no? So now the same circle, what's a in this case? A is 4. What would be the focus? The focus would be 4 comma 0, and this would be the center of this circle. That would be the center of this circle. Right? Sounds good? I want you to remember this. If a tangent in a standard parabola, if a tangent is drawn at t, then it intersects the x-axis at minus 80 squared comma 0, and the normal for a standard parabola intersects the x-axis at 2a plus 80 squared comma 0. A result again you would do good to remember. And the midpoint of AB will always be the focus a comma 0. In this case the focus a is 4, so focus is 4 comma 0. So this is a parabola. I want to find the condition so that this lies inside the parabola. Now this parabola is like y minus 2 whole squared minus 4 into x minus 3 equal to 0. And if I put y equal to alpha and x equal to alpha, this expression should be less than 0. S1 less than 0, right? So S1 less than 0 will cause it to lie inside the parabola. So we have y equal to alpha, x equal to alpha, alpha minus 2 whole squared minus 4 into alpha minus 3 less than 0, or alpha squared minus 4 alpha minus 4 alpha 8 alpha plus 4 plus 12 16 less than 0. Alpha is a real number. Alpha minus 4 whole square less than 0. But this is square of a real number. Can it be negative? No. So can I find any real alpha? No such real alpha. No real alpha. There is no real alpha for which alpha comma alpha lies inside the parabola. Because it's square of a real number. It can never be negative. Alpha minus 4 is always a real number. If you square it, it will always be a non-negative number. So I can't find a real alpha for which this can happen. Right? So we have essentially 3 points, E, F and G, T1, T2 and T3, such that their ordinates, that means their y coordinates, are in GP. That means 280T1, 280T2, 280T3 are in GP. That's given, isn't it? That means if 281, 282, 283 are in GP, it really means T1, T2, T3 are in GP. It means T1, T2, T3 are in GP. This is what it means. Right? Now, tangents at E and G intersect at P. What would be the x coordinate of P? X coordinate of P is A, T1, T2. T1, T3. T1, T3. X coordinate of P is A, T1, T3. Yes or no? But do you realize T1, T3 is T2 squared? Because T1, T2, T3 are in GP. So A, T1, T2, T1, T3 would be A, T2 squared, which is also the x coordinate of F. That means, you know, the ordinate P and F lie on the same vertical line, lie on the same ordinate. This is the same vertical line, means the same ordinate, because A, T2 squared, A, T2 squared is A, T1, T3. They have the same x coordinate. It's a line parallel to the y axis. This is what it means. Clear? So we have a parabola y square equal to 4ax, right? And its axis is the x-axis itself. This is a fixed parabola. 4x, isn't it? It's 4ax or 4x given in the problem? 4x, okay. And there is a moving parabola. There is a moving parabola. This is a moving parabola. And there are two conditions that this moving parabola enjoys. One, its axis is parallel to the axis of this parabola, that is the x-axis. And it always touches this parabola. It always touches this parabola. This is a condition for touching. That means they have a common tangent. That means they have a common tangent. That means this parabola intersects this parabola at two coincident real points. At two coincident real points. Two curves touch each other if they intersect each other at two coincident real points. These are two coincident real points, right? These are 2 points actually. They are coincident real points. Now, this parabola is moving obviously. So is its vertex. So is its vertex, h comma k. That means there is a locus associated with the vertex. There is a locus associated with the vertex h comma k. We want to be able to find the locus of the vertex of this moving parabola, right? Now, very clearly, you can see this parabola has to open in an opposite direction. It can't open in the same direction. It can't open in the same direction. It has to open in the, and the latest rectum of this is 4. The latest rectum of this will also be 4 because they are equal parabolas. They need, size of a parabola is dictated by its latest rectum, right? And its vertex is h comma k. So would you not want to believe that this parabola must be y minus k whole squared is minus 4 into x minus h? Would you not? I hope you realize why minus 4, because, right, the parabola has to open leftwards. So x has to be less than h. X has to be less than h so that this becomes non-negative, right? It has to open in this direction. And this 4 is the size of the parabola, latest rectum. Its vertex is h comma k. Yes or no? What am I seeking to find? I'm seeking to find the locus of h comma k, right? What condition have I not yet deployed? The fact that this curve 1 will always touch this curve 2. When would two curves touch each other? If their point of intersection are coincident points. That means when you solve these two equations, you must get coincident roots. You must get coincident roots, yes or no? Right now? Okay, so let me solve this equation. Then this xy, this point P xy will satisfy this condition as well as this condition. These are 2 points. These are 2 coincident points. This xy satisfies this condition. This xy also satisfies this condition. Now let me solve using these two equations, x and y. I should get 2 equal values of x and 2 equal values of y is what I should get. Okay, good. So now y minus k whole squared equal to minus 4. What is x? X is y squared by 4. X is y squared by 4 minus h. I get a quadratic in y, but I should get 2 equal values of y out of this quadratic. And when will that happen? If the discriminant of this quadratic in y is 0, right? So this is like minus y squared plus 4h, right? Let me transpose. So all of this is y minus k whole squared. So I get like a 2y squared minus 2ky plus k squared minus 4h is 0. What would this y give me? Y of p. But there are 2 equal p's. I should get 2 equal roots out of this. That means 2 equal real values of y means discriminant equal to 0. So 4k squared minus 8 into k squared minus 4h must be 0. So that gives me 4k squared is 32h, or k squared is 8h. So the moving point hk must always satisfy this condition. The vertex must have, so now I can generalize. That will give me the locus. So replace k by y and h by x, y squared equal to 8x, which itself is a parabola. Right? So the locus of the vertex itself is a parabola whose axis is also parallel to whose axis is actually the x-axis itself. Whose latest rectum is 8. Whose latest rectum is 8. Right? So now we have a parabola that passes through 2 points A and B. A is given to be A0 and B is given to be 0B. And this AB is also the shortest focal chord of the parabola. Hey, do you realize if this is a parabola, then the shortest focal chord will be the latest rectum, that will be the shortest focal chord, and it will also be perpendicular to the axis of the parabola. The shortest focal chord would be perpendicular to the axis of the parabola. That means the shortest focal chord will be parallel to the directrix of the parabola. The shortest focal chord will be parallel to the directrix of the parabola. Yes or no? Okay. Now, and the midpoint of AB must be the focus. The midpoint of AB must be the focus of the parabola. So the parabola that we are seeking has its focus S as the midpoint of AB, which is what? A by 2 comma B by 2. And this parabola, say, could be oriented like this, for example, but also could be oriented the other way. If this is the shortest focal chord, this could also be the parabola and this could be the directrix. Both possibilities exist, right? So in any case, what's the equation of AB, by the way? Can you tell me the equation of AB? What's the equation of AB, the line AB? X by A plus y by B equal to 1 is the equation of AB, right? This is my direct, Okay, so what we'll do is, of both these parabolas, 1 will pass through the origin. This will obviously not pass through the origin. So we'll eliminate the one which does not pass through the origin. That's what we'll do, right? So essentially then this will be the parabola. This will be the parabola, right? So there'll be only one parabola actually. There'll be only one parabola. So we'll eliminate the parabola which is not satisfied by 0, 0. Okay, na? Okay. Now the equation of AB is x by a plus y by b equal to 1. What would be the form of the equation of the directrix? X by a plus y by b equal to lambda. This will be a line parallel to that line, isn't it? So that will be the form of the equation of the directrix. Right now? Nahi kya? Minus lambda equal to 0 is the equation of the directrix. So essentially, if I can find lambda, I would know the equation of the directrix. And if I know the equation of the directrix, if I know the focus, I can find the parabola. Like we did in the past, right? Now, realize that distance of this point from the directrix, BM, must be distance from the focus. What's the distance of 0b from this line? Put x equal to 0, y equal to b. Distance of 0b from the directrix, put x equal to 0, y equal to b, right? So 1 minus lambda mod of this divided by root 1 by a squared plus 1 by b squared. That's the distance of b from the directrix, and that must be equal to distance of b from the focus. That means it will be half this length, right? Bs would be half this length. This length is root a squared plus b squared. So bs would be root a squared plus b squared by 2, right? Bs would be root a squared plus b squared by 2. Right? Now that will give me mod of 1 minus lambda is the same as mod of lambda minus 1, right? Mod of lambda minus 1 is half of root a square plus b squared into this, which is like root a square plus b squared by ab, right? Root a square b square, which is like a square plus b squared by 2ab. That's mod of lambda minus 1, right? Therefore, lambda minus 1 would be plus minus a square plus b squared by 2ab. Right? So one value of lambda would be, by taking the plus sign, so one value of lambda would be 1 plus a square plus b squared by 2ab. That's one value of lambda, which is what? You can see it's a plus b whole squared by 2ab. That's one value of lambda. Nahin? The other value of lambda is obtained by taking the minus sign. So I get lambda minus 1 equal to minus of a square plus b squared by 2ab. So if I transpose 1 on this side, so I get lambda equal to a minus b minus, if I take common, so a minus b whole squared by 2ab is what I get when I transpose 1 on the other side. Yes or no? So two values of lambda will give me two directrices. For each of the directrix, you can find the equation of the corresponding parabola and check which one passes through the origin. The one that passes through the origin will be our friend, right? So then we have this parabola y square equal to 4ax, and I take a focal chord a t1 squared comma 2at t1 and another point t2 on the parabola. Focus lies on this, etc. I want to show that the length pq of the focal chord would be a into t2 minus t1 whole squared is what I want to show. Now, SP is a focal radius at t1. Do you realize I have given you a result for this, a into 1 plus t1 squared? Have I not? Distance of a point t from the focus, have I given that result? A into 1 plus t squared? Right? Distance of focus from T2 would be A into 1 plus T2 squared. PQ is going to be the sum of these two, right? Which is A into, if I add these two, T1 squared plus T2 squared plus 2, right? This can be written as A into, say, T2 minus T1 whole square plus 2 T1 T2 plus 2. Yes or no? Hey, T1 T2 are the ends of a focal chord, so T1 into T2 must be minus 1, right? A property. T1 T2 is minus 1 for a focal chord, ends of a focal chord in a standard parabola. T1 T2 is minus 1. So this is minus 2 plus 2 will get cancelled. That's going to be A into T2 minus T1 whole square. A into T2 minus T1 whole square. The fact that the length of these segments, the harmonic mean is semi-lattice rectum, I have proved in the last class, right?